Hey guys, good morning or good evening. I got a new project. I've been working on this project, I guess, for the last 2 to 3 months on and off. It took a while to bring this telescope a shape. So I will go over the details of this telescope and I will actually show you building this telescope almost like from ground up, or you can call it assembling or putting together. It takes some time. I guess this is part one of this video. There are a lot more things to cover on this telescope. So I would split the video into 3 or 4 sessions. So for now, this is how to get up to this point. That's what this video is all about. And then we will go more into the details of other stuff. So this pet project is going on, and the reason why this project didn't work, you will know actually when you start looking at it, how complex things can get when you are dealing with multiple components. So let me go into the details. So first things first. So this is the tripod. It's relatively lightweight compared to the CGX-L, but it's heavier than the AVX mount. Of course, you have to level the tripod first, and you can have this tray or not, but I think this tray will help support putting things as well as supports the legs, I guess. So this is the first step. So this is the mount base. You don't need to take this base off. You can actually leave it on the mount. And this base goes on the tripod. Like there are 3 holes there which you need to align. So when you're taking this outside, you don't need to take the base off. You can actually take the mount along with the base, and it comes with like a little L pin. It has like 3 of them, the bolts. So this is the next step. Remember, there is a guy who holds this one on the Celestron website. I think he's holding a plastic one. This is heavy. So anyway, it has like 4 bolts on them, like 1, 2, 3 and 4. When you're moving to the left and right, to adjust the polar alignment, so you can actually make them a little loose, and then when you're done, use that L pin to make it tight so that the telescope stays intact with the polar alignment. These mounts are built like to go into the observatories as well. So if you don't move the mount from place to place every day, and if you are putting the mount in a constant place, exactly where you are putting the day before, and if you don't move, I think making this tight completely and leaving it there is going to make sense from a polar alignment standpoint. So these are the 4 bolts. So if you come closer, you see that arrow that has to be pointing up when you are putting the telescope on. When you are like storing it, you need to turn this other way around. So now the time is to bring the telescope. I'm sliding it from the bottom and then trying to see if I can close it off. So let me explain this a little bit. So this guy in the bottom, I have to get a Losmandy plate. It's a wider plate in the bottom. And then on the top, I mean, these rings came with the telescope, but I took the handle off from the telescope and I put a little Celestron, like a Dovetail plate on the top. So that way I can place something else on the top too here, right? And of course, so if you come closer, there are two pieces that we are dealing with. This one, I don't know if you can see it. So if you can see it, it's upside down. So this is a stepper motor from Moonlite. So this does the automatic focusing. This is Explore Scientific Focal Reducer and Corrector. And this one you see here is from Moonlite, the Rotator, right? So these are one on each side. The telescope itself is ED127, FCD 100, 127 mm. It's a triplet. I heard this does pretty good color correction. So the other cool thing to do is to make sure that these are connected. I'm just using hands to tighten these. I don't want them to be super tight, but they're okay. So it comes with this little Moonlite Focuser control. So you can actually connect the 1 and 2 here. I don't want these cables to tangle, so I'm putting them in the right. More than likely, this has to stay on the telescope, like somewhere here. I'm just putting some gaffer's tape so that it won't stain the telescope and it stays in the place. And once you know what you're doing, you can make the setup permanent. But so this is Pegasus Astro Pocket PC, and this has like 2 dew shield controllers. You can control this with software, and it has like 12 volts input, actually 1 12 volts input and 4 12 volts output. I'm just doing a temporary fix again. So it does need power for this one. So this is I guess one of the ZWO adapters for 12 volts. So now we got the Moonlite focus control ready. We put that in, right? We got the power for the pocket power box. We hooked the cables to the focuser and the rotator. So now we got to put the imaging camera and stuff. I found this little ring. I don't know if you can see it or not. This is ZWO Off Axis Guider, but this tiny little ring can make it go inside. All right. So this is ZWO filter wheel. It's like 8-position filter wheel. It has this little cap on the top, right? So the camera goes in there, and this side should go here to this spot. So what I'm looking at is, okay, let's go over this filter wheel a little bit. So this is, one is empty. There is nothing, no filter there. So this is luminance filter L. This is H alpha, hydrogen alpha, O3, right? This is oxygen. This is sulfur S2. This is R, like red, green and blue. So these are all astronomic RGBs. The filter wheel, if you buy the set kind of thing, I think they give you the 7 nanometers one, but I believe the 6 nanometer ones are slightly better. All right, so the one is empty. It goes by default to the one. And what I'm looking at is, did you notice, like, I put the focuser, the focal reducer, and then I put the off axis guider here. The idea is off axis guider stays before the filter wheel comes. The reason for that was, if you are using like a narrowband imaging, and if you are using like a hydrogen alpha or oxygen or sulfur kind of thing, and if you put your off axis guider after your filter wheel, you are getting like very less light because of the filter, and you may not be able to see the guide star. Your guide camera is not as powerful as your imaging camera, so you got to you have to make sure you do this first. Helps, I guess. The flat side, when it is flat prism, like it has to go this side. It exactly goes to this side, so well, anyway, I don't want to make it too tight right now. I might have to take it out, so it does work. Okay. So this is Orion StarShoot AutoGuider. So this tiny little camera goes here. So there is a nose piece that I can put it in here, and of course this one has to go in this one, and you have a little room too on top of it, and this guy can go here. It's pretty tight. And now this one, all right, that'll work. So the camera stays on this side, looks like. We have to figure out. If one goes in, we are good. At least it will hold. I'm not putting all the screws in because I may have to like dust the filters a little bit again, and also like you don't know what's going to happen. So I have a bunch of screws here laying on the ground, and this is ZWO 1600 mm. All right. So let's go over this again. So we got the imaging camera hooked up. We got the guide camera. We have the off axis guider, the filter wheel in front of it. We have the focal reducer, and then we have the rotator and the focuser. Of course, the telescope itself. Now we got to run some cables for these two into the computer. Of course, for this one too, and this one too. Okay. So I did a little bit of twisting, turning, all that, and then I moved this from here to here up because I think it's easy to slide without any trouble by moving this up. And then put a little tape here, like this is still temporary setup, but as you can see, I put a little tape here for this one. This is the power, and this is that. This is the 12 volts adapter that goes into the pocket power adapter. It's kind of balanced at this moment, I would say. I think the mount can handle the remaining balance. Zip ties locks themselves up, so and this thing right here is saying CGX ready. Okay, so before you do anything, make sure you have your RA and the deck clutches on. And I don't know if you can see, it says CGX ready, and we need to press enter. It says set switch position. Basically, this goes to home position when you press it. So it's going to the home position right now. So I put my latitude, longitude, as well as the date and time into this mount. And I used an option called Quick Align, and I'm good with that one for now. I just wanted to make sure I can move the mount. So let's get the camera going. I'm just plugging in my laptop. So if you can see, it shows like a little bit tiny bit of light right now. That's what it is showing. So I have to focus it. So I'm trying to turn on the focuser at this time. So anyway, after few minutes of moving the telescope around, I was able to get the focuser point to some, and it is actually kind of focusing. This is still a manual focuser, and this is a part 1 of my video. I will have to still do a lot more setup, and I wanted to show you a lot more in part 2 of this video. So let this stop for a second, and I'll show you how the rotator works as well. So if I click the, I guess, few things here, you see that, I mean, if you want to see a little bit more, it rotates the image. You know, when you click on that rotation of the image. So the focuser and the rotator are working. I have to still make sure the off axis guider is set up. I still need to do balancing of the mount. There is quite a bit work that needs to be done. So I'll put part 2 or maybe part 3 of this video, how I completed the install of this one. Thanks for watching. Please wait for part 2 of this video, or maybe part 2 or part 3 as well. Thanks for watching.